Hello, friends, and this is Alvin again. And today we are going to solve as 12th standard examinations are on, and we have to think about some haunting problems, like problems when they come into examination. And whenever we look at the problems like these, if you can't see it clearly, I will write it down a little bigger for you. And the problem is like this. This problem is sec in bracket summation of k is equal to -1 to 2018. So you have to add this from k is equal to -1 to 2018 cosec tan cot of sine of cos of 4k plus 5 upon 20 pi, and we have to find the value of this. It's a very haunting problem. It is a very difficult problem. It seems like that, but we will try to attempt this problem, and we will try to find the answer of this problem. So where do you start with? See, as you can see, this type of problem is nested function. So there is a function, inside that there is a function, inside that there is another function, inside another function, and so on. So there is a cosec, tan of cosec, so cosec of tan of cot of sine of cos of, and then the angle. So this problem is generally for the 11th standard students, and they can know how to solve this problem just by thinking in a very different way. The problem in itself, I think this problem is going to cancel out each other. Why do I think like that? It is because of cos term or sine term, and as I know that trigonometric functions are actually periodic function which repeat themselves after the angle of 2 pi. See, I will just draw a graph of how cosine function works. Cosine function, if I draw a graph of angle, that is, if this is x-axis, and on x-axis I am drawing theta, and on y-axis I am going to plot cos theta. So I am going to get something like this. So it is going to be +1 when and -1, and your function is going to fluctuate between this +1 and -1. So cos theta will never be greater than +1, and cos theta will never be less than -1. It is going to be only in between +1 and -1, because we know that cos theta is nothing but, if you draw a right angle triangle, cos theta, if this is theta, it is always adjacent side, suppose this is A, upon hypotenuse side, suppose it is C. So we know that hypotenuse is always greater than the adjacent, so A upon C will always be less than 1. So this is positive side. When you draw a graph, it is going to go +1, -1, and so on and so forth. So I should only find out the values. This is going to be periodic, and I know one thing, that in this wave, this is a wave-like structure. In this wave there are some values which will give me some value. Suppose this is A. I can find the same value but negative on the other side, as you can see it here. So that means if this is theta, this is theta, this is here till here, it is, when cos is 0, it is pi/2, and same theta. So cos theta is equal to cos of pi plus theta. So negative, I am sorry, right? So cos of theta is always negative of cos of pi plus theta. So this relation we know already, but what I am interested in is that how to solve this problem. right? Some information I have, some bits and pieces of information that I'm going to put it together to solve such type of problems. So I know one thing, that cos of theta, it is negative of cos of pi plus theta. So if I get cos pi plus theta, I can directly write it negative cos theta or minus cos theta. So I can write cos of pi plus theta, I can write it equal to minus cos theta without even thinking of anything. Okay, that is the arena set for this problem, and now I'm going to attempt to solve this problem in a slightly different way, because what is this problem? We will first define the problem, what we are actually going to do, and how we are going to make it much more easier to do the same thing. Alright, let's start. Now this is summation. Now don't concentrate on this sec, but this whole complex function is there. We will concentrate on this. So k is equal to 1 to 2018. So what does that mean? It means that I'm going to put k is equal to 1, minus 1 first, calculate this whole thing, okay, put it aside, suppose the value is a. Then I'm going to put next integer. What is after minus 1? Next integer after minus 1 is 0. So I'm going to put k is equal to 0, calculate this whole thing, suppose the answer is b. I don't know what the answer is, right? So to calculate these things it's very difficult. So this is nowhere, I can't calculate it. So, but the answer is, suppose it is b. I'm going to put it aside. Then I have to put next integer, next integer, next integer up to 2018. I have to repeat it. I have to add all those 2020 numbers, because from minus 1 to 2018 there are 2020 numbers. So all those numbers I have to add, and then whatever value I am getting, I have to put it here, take the secant, that is sec theta of that, then I am going to get the value of this function. So it's a big task, and I don't think half hour is also required for such kind of things, but half an hour is not required, because we can use our logic to simplify these things. So how do we simplify these things? Is because I know that this cos theta is going to become negative at some point, and hopefully I'm going to get those values which are negative of this. Suppose if I get a, I'm hoping b, c and d, and after some time I'm going to get minus a, minus b, minus c, then again plus a, plus c, plus c, plus d, and so on, so that every addition is going to come to 0. There is other thing you have to identify about this problem, is that when cos becomes negative, sine also becomes negative, because sine of minus theta is equal to minus sine theta, right? So this is one property that we know about sine theta. Cot of minus theta, when sine becomes negative, cot also becomes negative, because cot of minus theta is equal to minus cot theta. When cot becomes negative, tan also becomes negative, and tan becomes negative, cosec also becomes negative, because cosec is inverse of sine. So sine negative, it becomes negative sine. So these are the things that we need to first follow. Now I'm going to go to the crux of the problem. First of all, I'm going to take some values and see where cos theta becomes negative of itself. So we will start. So first, when k is equal to minus 1, I'm going to put this cos theta. So cos of 4 into minus 1 plus 5 divided by 20 into pi, it is equal to 4 into minus 1 is minus 4, and minus 4 plus 5 is 1 into pi divided by 20, which is equal to pi by 20. So it is cos, so cos pi by 20, and this is also cos pi by 20. Again, when k is equal to 0, next integer, it is equal to cos of 4 into 0 plus 5 over 20. So it is going to give you into pi, and it is going to give you 4 into 0 is 0, and it is going to give you cos of 5 pi over 20, which is equal to cos 5 1s are 5 4s are, it will be cos pi upon 4. So cos pi by 4 is nothing but it is cos 45, and when k it is equal to 1, I am going to get cos of 4 into 1 plus 5 upon 20, pi, so it will be 4 plus 5, it is equal to cos of 9 pi upon 20. K is equal to 2, so it will be equal to cos of 4 into 2, because I am putting k, instead of k I am putting 2, 5 upon 20 into pi, which is equal to 8 plus 5 is cos of 13 upon 20 pi. When k is equal to 3, it is equal to cos 4 into 3 plus 5 upon 20 into pi. It is 4 3 is 12, 12 plus 5 is 12 plus 5 is 17, so cos of 17 upon 20 into pi. What do I get when k is equal to 4? So again I am going to put cos is of 4k, that is 4 into 4 plus 5 upon 20 into pi, which is equal to cos of 4 4s are 16, 16 plus 5 is 21 upon 20 into pi. Now it's a lot of hard work, but we ultimately reached a numerator where numerator is bigger than the denominator. You can see here the numerator is always less than the denominator. So pi upon 4, it is 9 upon 20 pi, so 13 upon 20 pi, and so on. So cos of 21 upon 20 pi can be written as cos of 20 plus 1 upon 20 pi, which is equal to cos of, I can divide it 20 upon 20 plus 1 upon 20 into pi, which is equal to, again it is cos of 1, because 20 20 gets cancelled, plus 1 upon 20 into pi, which is equal to, again cos of, I am going to multiply this pi inside the bracket, it is going to be pi plus pi upon 20. So what is cos of pi divided pi plus theta? Cos of pi plus theta, it is equal to negative cos of pi over 20. That's it, guys. Now you have to think a little. From k is equal to minus 1 all the way to, after these 5 terms, 1 2 3 4 5, after 5 terms, the 6th term becomes negative of the first term. This is, I got here cos pi by 20, I got there cos minus cos pi by 20. So this cos pi by 20 and this minus cos pi by 20 is actually going to cancel each other out. Why? Because this is cos pi by 20. If I put it here, there will be some value of this cos, and sine value of that will be this, that, and we will get some value of this. Let's say that value is x. If I put, instead of here, if I put 4, when I reach k is equal to 4, I am going to put this value, that is negative, and the negative sign is going to transfer and it is going to give you minus x. So what is x? Minus x, it is going to get cancelled out each other and it is going to give you the answer 0. So this is x minus x is 0. This term and the 5th term, when k is equal to 5, is going to cancel out each other out. Then you are going to get the repeated cycle, because cos theta is actually works on cycles. So one value and you get the negative value, they are going to cancel each other out. So I am going to get this summation, I am going to get some positive values, 5 positive values, and then 5 negative values, then again 5 positive values and 5 negative values, which will cancel each other out. And how many such sets are there? There are, from minus 1 to 2018, there are 2020 additions that we have to do in this whole thing. So that means if I divide it by 5, I am going to get 404, that is 404 numbers. That means there are 202 positive numbers and 202 negative sets, which are going to cancel each other out, and this whole addition is going to give me a 0, because every number is going to cancel each other out and we are going to get a 0. So we get sec of 0, right? I'm just going to do this, and I'm going to write here. From this I'm inferring that summation from k is equal to minus 1 to 2018 cosec of tan of cot of sine of cos 4k plus 5 upon 20 pi, this whole thing is equal to 0. So when this becomes equal to 0, I just have to substitute the summation. It is going to be sec 0, and we know the value of sec 0 is equal to 1. So this whole value is equal to 1. Folks, the question is haunting, but the answer is very simple. Thank you very much.